Hey, welcome to the slideshow for exercise 10 from the flight training manual, which goes over flights for range and endurance. So what are these two things? So range is the maximum amount of distance that you can fly given a certain amount of fuel, and endurance is the maximum time aloft you can stay given an amount of fuel. So it's really the amount of fuel that's constraining on how far you can go or how long you can stay in the air, but fuel consumption is not constant across all power settings. So you can actually change your power setting to change your fuel burn to change your maximum distance or maximum time aloft. So grab a POH and look at the range and endurance profiles of a Cessna 152. So you have endurance expressed in hours and you have range expressed in nautical miles. Taking the line furthest out, you can see that in both cases, 45% power is going to give both the best range and the best endurance. As we increase power to 55, 65, and 75%, both your range and endurance for a given tank of fuel will decrease. Well, what does 45% power mean? So flip over to the cruise performance chart, and this chart gives cruise performance for a Cessna 152 at different pressure altitudes and different temperatures. As an example, take a flight at 6,000 feet in standard temperature, that's the middle column, shows that an RPM setting of 2,000 RPM gives a brake horsepower of 45%. The resulting true airspeed is 79 knots, and the fuel burn is 3.7 gallons per hour. Increasing the power to 2,500 RPM gives you 75% brake horsepower, true airspeed of 105 knots, and a fuel burn of 6.1 gallons per hour. So there you have it. You know from the range profile chart that you find the power setting that will give you the maximum range, which in this case is 45% power. Select that for your en route power setting, and that will give you a fuel burn and a true airspeed for that flight. But some of you might be flying a 172 model and you might be like, hey, Yvonne, that's not what my charts look like. Mine is showing that at 55% power, I'm getting better range. And without getting too technical on this, due to drag characteristics, the 172 model actually has a better range when flying at a slightly higher power setting than its best endurance, which shows at 45%. So let's talk about drag for a minute. Okay, so going back to the flight training manual in exercise 10, you'll find a little graph that looks like this. What it's showing you is that there are two types of drag that are acting on an aircraft. Induced drag is a byproduct of lift, and it decreases with velocity. Parasite drag includes form drag and friction drag, and it increases as your airspeed increases. Therefore, total drag, which is both of these combined, is minimized at the airspeed where your parasite drag overcomes your induced drag. If you fly any slower than this speed, your total drag increases, and if you fly any faster, your total drag also increases. So this airspeed represents that minimum lift drag ratio, and it minimizes your total drag. So what the 172 charts are showing is that your maximum range, power, and associated airspeed are minimizing drag, and that your maximum endurance power and associated airspeed are slower and lower than your maximum range power and airspeed. Let's look at why that is. Okay, so let's look at the power available versus power required curve. And the power required curve is the lower curve. Notice on this chart that the minimum point of the power required curve is slower than the LD max point, which minimizes drag. So what this is showing is that at a higher airspeed, it will give better distance per unit of fuel burned due to the minimized drag. But we can sacrifice some of that distance gain for increased lift at a cost of higher drag, and that will give us a point of maximum endurance. So now you understand the difference between maximum range and maximum endurance, and you know how to find them from the aircraft POH. But is your maximum range power setting and airspeed from the POH always going to give you the maximum range for your aircraft? And the real answer is no, it won't. Not only can things like aircraft weight, center of gravity, and mixture or leaning have an effect on your maximum range of your aircraft, but winds aloft and turbulence can also have a significant impact on how far your plane can fly. The performance charts that you saw in your POH assumed a no-wind condition. There may be times when headwinds aloft will affect the ground speed of your aircraft, and that could actually affect the range that you have per given amount of fuel. In situations with a strong headwind, for example, it might be prudent to adjust your airspeed to reach your destination sooner and therefore spend less time in the air fighting that headwind. In the example shown below, if you're fighting a headwind of 40 knots and your destination is 300 nautical miles away, you actually get better range out of your aircraft if you select a higher airspeed despite the extra fuel burn. because you'll reach your destination sooner and actually have fuel to spare. So in the example below, the airspeed on the bottom is only 10 knots faster, and the fuel burn is 7.5 gallons instead of 6.75 gallons, but you actually get better range out of increasing your airspeed by 10 knots. So that's the first part of this exercise that we will be reviewing in the airplane. It's how to determine, using the POH, what the no wind, maximum range, airspeed, and power setting will be, and then we'll go ahead and verify this in the airplane on your next flight. So this is part of your homework. Given the atmospheric conditions of the day, plan pressure altitude of the flight, calculate what the indicated airspeed will be for that power setting. Now we're going to look at maximum endurance. So remember from the pilot operating handbook performance charts, we had 45% power as our best endurance power setting. But we know that as we reduce power, we can also reduce our fuel burn. And since our goal is to stay in the air for as long as possible, not in the previous case, which was to fly as far as possible, my question is, can we reduce our power and our fuel burn any lower than 45% and remain airborne? So we're going to do this by setting up in cruise and then reducing power in 100 RPM increments while maintaining altitude to find out what is the power setting that is the minimum amount of power required to maintain altitude. As a quick reminder, let's go back to straight and level flight at various airspeeds. So remember what happens when you reduce power. The nose will tend to fall and yaw to the right. So every time that you reduce power, you'll want to prevent any loss in altitude by catching that drop and bringing the nose up higher to produce a bit more lift. What you're going to notice is that as we reduce the power, we're going to need to increase the airplane's angle of attack to get more lift at a cost of more drag. As we pass through the power setting that gives us maximum range, you're going to notice that we can continue to reduce power and not lose altitude. We are trading that extra lift out of the wing at a cost of more induced drag. And we're going to keep on doing this until we find the amount of drag produced by the wing starts to overcome the additional lift produced by that airspeed and power setting. And it's going to look like this. We're going to start out at 2300 RPM, maintain altitude at 2000, let's say, and you're going to record your airspeed. And then you're going to reduce to 2200 RPM, 2100 RPM, 2000 RPM, each time maintaining your altitude and recording your airspeed. And what we'll find is that there is going to be a certain level of power where if we try to reduce power, we'll no longer be able to maintain altitude. Just some really quick notes. I want to talk about the use of flap because yes, even though flap can give you more lift, they actually give you way more drag as a result. So in your situation where you want to stay up in the air for as long as possible or even get the best range, you never want to use flap because they're really just increasing and adding additional drag on your airplane. Also, we're going to talk about leaning in the airplane. We're going to talk about how you lean and why you want to increase your mixture as you go into a descent or an approach for landing. All right, so that lesson was pretty heavy on the theory. Don't worry, this flight is actually relatively quick. But if you do have any questions on the material that we covered, make sure you ask them before your next lesson. And we're going to be building on this material for the next 2 lessons, which are slow flight and stalls. So just make sure that you do have a good grasp on the theory. Cool, have a great day.